Good morning. I am Dr.G.Senthilkumar from Department of Mechanical Engineering. So the today topic is nanobubbles for engineering applications. Before moving to this topic, irrespective of all the disciplines of engineering, students are doing projects related to nano. So generally nano means 10 power minus 9 meters. So these nanobubbles comes under the family of nano. So nano generally called as nano droplets and nanoparticles. In heat transfer fluids, these nanoparticles plays a vital role to improve the thermophysical properties of the normal fluids because the existing heat transfer fluids possesses very poor thermal conductivity. But the powder shaped forms called as the nanoparticles, if we add to some extent, they can enhance the thermophysical properties of the heat transfer fluids. On the other hand, the general category called the nano droplets. These nano bubbles are the family of nano bubbles. People always knows about nanoparticles, but this nano bubbles is a new technology in which the nanobubble size is about greater than 10 nanometer. As I already told, it is a family of nano droplets. Why we are using it? Because of their excellent characteristics. For example, they have a very large surface area density. What is the surface area density? If you take 1 meter cube volume of any liquid, let us say water, these nanobubbles occupy maximum area, that is called surface area density, that is meter square per meter cube, and they have long lasting phenomenon. The thing is that the nano bubbles, they are called the gas filled cavities, they have a very high internal pressure. Because of this internal pressure, they cannot burst easily. That's why they have the high stability. They can live in liquids for a long duration. Okay, where it is being used? Already it is being proven records. For example, wastewater treatment, aquaculture, domestic cleaning of vessels, seed germination, agriculture, water quality enhancement, yeast cultivation, drug delivery, and even IC engines. All the fields, there are proven records are available that nanobubbles find a very huge applications in these areas. This is what we are going to discuss in our slides one by one. As I mentioned, they are the tiny bubbles. They are very small bubble sizes of with different the unique physical and mechanical properties. Large internal pressure. That internal pressure is called the Laplace pressure. Compared to the atmospheric pressure, the internal pressure of the bubbles will be 30 times greater. Right? So the distinct properties of nanobubbles, that is 10 nanometer and up to 200 nanometer, make them to use in almost all engineering fields, biotechnology, mechanical engineering, chemical engineering, almost all the engineering fields we are making use of these bubbles. Generally, the size of nano means 10 nanometer, but in case of nanobubbles in water, it can go up to 100 nanometers. You can look at this picture, how the bubble growth happens. If the bubble size prolongs, that means that they can resist the gravity. Because of the buoyancy, the large bubbles can move to the free surface and they will burst. But if the bubble size is very small, let us say nano size, they will not have the vertical movement. Instead, they will have the lateral movement. They will settle in the liquid itself and yielding a very good mechanical and thermal properties. So I told generally bubbles. So let us categorize according to the size. So you can see this slide, macro bubbles, the diameter will be above 100 micron meters. That is called macro bubbles. And when it comes to micro, it is up to 100. That is from 1 micron meter and up to 100 micron meter. That is called micro. And nano means maximum size itself 1 micron meter. That is the smallest size will be about 10 nanometer. So nano means it is a gas filled cavities in liquids. Any gas we can induce in any liquids to enhance some properties. So long term stability and bubble size distribution. How the bubble bubble means generally spherical in shape. How the bubble distributes in the water. So it purely depends upon the solubility ratio of the gas in the water and also proportional to the salt concentration. And there is one parameter called zeta potential. What is this zeta potential? This is the negatively charged potential which is used to measure the stability of the bubbles in the water. Lower the values of zeta potential, higher will be the stability of the bubble. Stability in the sense the bubble can retain for long duration from weeks to years. The bubbles generally proportional to the pH values. The bubbles will be more stable in alkaline solutions, that is pH greater than 7, the bubble stability will be higher. So zeta potential and bubble movement due to, if you see the Brownian movement is 3-dimensional, right? So the bubble can travel in all the 3 axes, x, y and z axis, and presently all the nanoparticle tracking analysis and any other type of analysis, they can do analysis only in 2 dimensions only. That is another constraint to study about the molecular dynamics of these nanobubbles. Why this topic? Why these nanobubbles we are telling that is a remarkable, as I already told, people keep on concentrating on the nanoparticles rather than nanobubbles, but this nanobubbles is a new trend, and why it is being remarkable? So it is different from large bubbles because they are nanoscopic, that is 10 nanometer size also it is possible to produce. So their stability, surface charge, neutral buoyancy, that is what I told, they cannot travel to the top surface, instead they can move in the horizontal direction, and oxidation are the result of their size. Lower the size, more will be the oxidation capabilities. And what are the some benefits of these nanobubbles? So the nanobubbles, for example, 70 to 120 nanometers in size generally. If you take a small grain of salt, okay, so compared with its small grain of salt, this nanobubble size is 2500 times smaller. So you can imagine how much size it is. So it is about 70 to 120 nanometers. So we can generate nanobubbles with different methods which I am going to discuss next, either by injecting the gas into the liquid. Okay. So the nanobubbles are used to improve the numerous physical, chemical and biological properties. So they have a long negative charge, that is called the zeta potential, that is responsible for keeping the nanobubbles more stable in liquids and enable them to continuously participate in all the applications. So they are the smallest known of bubbles. I already told that it is about 2500 times smaller than the salt. So they have the neutral buoyancy, they cannot travel vertical, instead they will travel only in the lateral directions. So that make them more suitable to have the stability from weeks to long. What is this hyper efficient aeration, oxygenation and gas transfer? Aeration means injection of the air to the any liquid, let us say water. Oxidation means instead of air we are injecting the oxygen to the liquid to enhance the DO, that is called dissolved oxygen. So conventional aeration techniques, if you see this, they have only 3% oxygen transfer efficiency under standard conditions, whereas this nanobubble technologies having 85% of oxygen transfer efficiency compared to the conventional techniques. So compared to this scalable gas transfer methods, the nanobubbles are superior because they remain suspended and dispersed to deliver gas throughout the liquid volume. That is one case, and they will be stable for until they have interact with the surface, until they have the collide with another particle, they will be stable, and they have the tendency to transfer the gas to liquid until they collapse. This is another unique characteristics because of their size and structure. They possess distinct properties that make them applicable to improve the water quality. Frankly speaking, we don't have fresh water to drink. In future, we have to desalinate the wastewater. That is the only solution to have the drinking water. For that purpose, the nanobubble going to be a very good opportunity to treat the wastewater, and that is water treatment purposes. And in addition to that, industrial and agricultural applications also, starting from seed germination or any other type of seed and cultivation of yeast, aquaculture, for all the applications, we can induce this gas in the liquids so that the oxygen transfer efficiency will improve. So with this neutral buoyancy molar nanobubbles and to ensure that total surface area to enhance so that the bubble can retain for the prolonged duration. And second, the zeta potential plays a vital role so that the stability of the bubble can be ensured from weeks to years. And when nanobubbles are stimulated, for example, they destabilize and collapse. That is the one problem. They should not get stimulated. That time they will release the hydroxyl radical. This hydroxyl radical is one of the strongest known oxidizers, contributing for killing the that is bacteria and viruses, all the pollutants, so-called contaminants present in the wastewater. You can see here, I already told some generation methods for the nanobubbles: hydrodynamic cavitation, carbon material deposition, direct water deposition method, temperature exchange method, electrolysis, and solvent exchange method. In this figure, you can see this is called the hydrodynamic aeration. Here we are inducing the air through the tank which is filled with the water, inside which we have the nanobubble generator. When the air enters, due to the shearing action, the gas split into nano size. And because of this, whatever the contaminants present in the water will get moved to the top surface and being removed. This is the main benefit of this nanobubble technology with this air as the application. So next, oxidation means we are inducing the oxygen gas. We need a oxygen cylinder. Through the cylinder, we will introduce the oxygen gas to the water. So this oxygen gas, under very high internal pressure, when it impinges on the water, it splits the water molecules, so that whatever the contaminants will present will get encapsulated by these oxygen molecules, and they will travel to the top surface so that we can remove them easily. This is called the nanobubble oxidation. And many testing proved that this hydroxyl radical is one of the strongest known oxidizers, and we can make use of these nanobubbles to mitigate the algae blooms, and they are also used for removing the compounds that cause off flavors and foul odors. And whatever the precipitate metals and degrade water contaminants, they can also be removed from this nanobubbles technology. In addition to this, for example, if oil get mixed into the water or any other fluid get mixed into the water, that can also be possible to removed by this nanobubble technology. So these nanobubbles naturally adhere to suspended, colloidal and emulsified materials, causing them to clump together. So they can be easily removed from water by filtration or flotation. So nanobubbles have been used for various physical separation processes to remove oil, for example, colloids, fine particles, solids, fats and grease, also surfactants. And surface scoring and compact buildup, this is also possible by using these nanobubbles. They can effectively prevent and remove unwanted buildup that is created in the wet environments. And nanobubbles are proven effective at removing and preventing the film growth on submerged surfaces, including pipe interior surfaces and food washing surfaces. Scale incubation and prevention. Whatever the scale formation which occurs in the pipelines due to the continuous flow of the liquids, that can also be prevented by means of this high pressure gas which is introduced into the pipelines. So hydrodynamic cavitation. So what is this hydrodynamic cavitations? So inside which water is pumped into the nozzle, which is placed inside the tank with the eccentricity to create a swelling effect, that is called the shearing force which I told. This swirling water creates a vacuum at the outer surface of the nozzle where the desired gas will be injected. So the gas introduced by vacuum into the swirling water will exit from the outlet as a mixture of micro and nano bubbles. We cannot say that by using this air or oxygen we can generate only nano bubbles or micro bubbles. That can be decided by some special techniques for NTA, non-destructive, that is nanoparticle tracking analysis or SEM analysis, like that. So the nanobubbles, we have the facility to generate the nanobubbles in a water tank which has a capacity of 130 liters. So the maximum we can fill up to 100 liters waters. We have the provision to do the experiment with the aeration, oxidation or cavitation or any other gas we can introduce into the water, so that we can see the effect of this gas into the water due to this nanobubble generation. And what is this, how to measure the size distribution and zeta potential? So the bubble size distribution and zeta potential values are being measured by means of the zeta sizer. Zeta sizer uses dynamic light scattering technique by which we can able to analyze the particle size and distribution very clearly. And stability and reactivity of the nanobubbles definitely depends upon the gases inside the cavity. So what type of gases we are using? whether it is a nitrogen gas or CO2 gas or oxygen gas, that also decides the stability of these nanobubbles. So, to investigate the different bubble properties, nanobubbles were generated using different gases, let us say ozone also possible, oxygen also possible, air, nitrogen. So, bubbles were generated in, for example, DI water, where the electrical conductivity of the solution was maintained at 0.3 milliseconds per centimeter by adding NaCl solution. So, what is the scope? Because the topic, the hot topic is nanobubbles engineering applications. So, these are the research aspects where we can concentrate on this nanobubble technology implementation to various engineering applications, that is dissolved air flotation method to separate oil from water, and wastewater aeration. Aeration means introduction of the air into the water by nanobubbles. VOF, that is the volume fraction measurement, also possible in case of multi-phase fluids, and multi-phase heat transfer, porous medium thermal analysis, ozone production, and nano air bubbles for CRDA, okay, common rail direct injection engines. We can make use of this nano air bubbles, airlift loop bioreactor to produce the algae biomass, rapid humidification in case of the desalination plants. So, these are some research areas. In addition to this, you can see fluidic oscillator for energy efficient microbubble generation processes, salt content in groundwater also we can able to examine by using this nanobubble technology, and by introducing the different cases, for example, nitrogen in control water to reduce the DO, and in the other case, if you introduce the oxygen, we can able to increase the DO content in the water, so that the water quality can be increased. So, the wastewater can be made as a drinking water. So, these are some applications where practically being implemented, this nanobubble technology is being used already, wastewater treatment plants, nano research labs, and irrigation. So, the main problem is agricultural. Nowadays, our farmers are facing the water scarcity issues. So, instead of this bulk water, that is the bulk sized water we are using, if you use the particles, that is nano sized water, that is nano bubbles enhanced water, we can able to enhance the yield. That is the main application of this nanobubble technology in case of the irrigation field. This is one of the case studies which we already did called these micro nanobubbles for the wastewater treatment. So, here we are able to treat the groundwater for the TDS reduction, total dissolved solids, and water quality can be tested by using the different tests, and it was ensured that after nanobubble generation the quality was improved. So, the conversion of raw water to drinking water is the main aim of this experiment, and total running cost and time also we can minimize compared to other techniques. So, to achieve the conversion of any kind of water, even the sea water also, it is possible to convert into drinking water. The conversion efficiency also very high. There are plenty of techniques are available to convert the sea water to drinking water, but the nanobubble technology possesses very good applications compared to other techniques. So, whatever the standard particles which are present in the domestic wastewater, which causes the water to be contaminated, can be removed by using this M&B technologies, that is micro nanobubble technologies. So, the major portion of the research of fluids is about desalination, because in future, as I already told, we do not have the fresh water to drink. So, the only solution is the desalination, and the desalination is also effective by using this nanobubble technology. This is what I want to emphasize in this topic. So, the focus towards desalination with micro nanobubble technology has progressed very rapidly in the past few decades. So, that is why I am telling that this is the latest technology. So, the water quality and its availability are still a challenging task due to growing industrialization and urbanization. So, we are not able to meet out the people's water, how much quantity of water has to be drink, everything to be controlled now. Okay, so in general, the micro nanobubble technology can replace the existing activated sludge method for removing the impurities from the wastewater. So, the attention towards the research to bulk nanobubbles increased intensively nowadays, so that wastewater treatment can be possible by using these nanobubble technologies. And if you see, these air nanobubbles are simply called as nanobubbles, or the part of nano family. Due to their unpredicted manner, the research is still progressing. So, the research is not completed. Still there are lot of scope for this nanobubble technology. So generally the micro nanobubbles formation is undesirable in some cases. For example, nuclear reactors, there will be some argon gas in case of the sodium cooled reactors, which is undesirable. But in many cases, we want the gas to introduce into the water so that the water will become purified. So the air nanobubble application is considered necessarily in many fields, as I already told, aquaculture, wastewater, agriculture, yeast cultivation, drug delivery, and many other applications, seed germinations. So the constant negatively charged potential, as I said, the zeta potential is the one which ensure the stability of the nanobubbles in the water. So generally the nanobubbles are the gas filled cavities in a liquid medium. So bubbles of diameter between 100 micron meters and 2 mm can easily travel to the top surface because they are macro size, right? So they will travel to the top surface because of this density difference, and once it reaches the free surface, they will burst. But the bubbles of size between 1 micron meter and 100 micron meter can easily dissolve in liquids itself. They will not have the vertical movement, instead they will have the lateral movement called the micro bubbles. And particularly if we come to nano, that is 1 micron meter and up to 100 nanometer, they can remain in the liquid for a long duration, even for months. Okay. So the two classes of nanobubbles are called bulk nanobubbles and surface nanobubbles. So the bulk nanobubbles are the gases created within the liquids itself. Surface nanobubbles are created between the gas particles and the surface, that is the container which is holding the water or any other liquids. So the bulk nanobubbles were the gas filled cavities. So there is one method called Hadamard efficiency model which explains the Laplace pressure. Normally the gas filled cavities nanobubbles possesses a very high internal pressure up to 30 atmospheric pressure, because the water which is 1 atmospheric pressure, but the bubble internal pressure is 30 times greater. Okay, that itself make the bubble to collapse like anything and making the size again and again to reduce. So that's why we are able to get the very fine bubbles so that all the contaminants we can remove. So the extraordinary retention period, that is the long lasting of these bulk nanobubbles in liquids, is still contrary to the present theory through the initial investigation started just 4 decades. So this increasing research interest on this BNB, that is bulk nanobubble, till today is not only due to their physiochemical properties, but also due to their extensive use in all the fields, not only engineering, medical, wastewater treatment, groundwater remediation, cultivation and propagation of the yeast, froth flotation, ozone generation, algae production, oxygenation of blood, surface cleaning. So many applications. So this is one of the photographic view of a micro nanobubble generator which is already being established, by which we can do, as I already mentioned, some methods: hydrodynamic cavitation, hydrodynamic oxidation, or any other type of gas we can introduce inside the tank. By filling the tank with the water, we can able to create that Laplace pressure which is 30 times greater than the normal atmospheric pressure, by which all the contaminants we can remove. These facilities we already have. So this is the side view of this experimental setup, that is micro nanobubble generator. This is the main device, which is a stainless steel vessel which possesses a nozzle inside. So whatever the gas we are introducing, which splits the gas, which creates the shearing action between the gas and the water, can be achieved by means of this diamond shaped nozzles which is enclosed in this vessel, that is SS vessel. Okay, so this is the complete view of this experimental setup. You can see that the SS vessel which is placed inside the water tank, right? So the water tank of already I mentioned in the slide, it is 130 liters capacity, but we can fill the water up to 100 liters, and we can introduce any gas inside the water so that whatever the pollutants present, we can make them to travel to the top surface, and using the specific filters, TDS filters or TDS filters, we can able to remove the pollutants. So this is the another photographic view of the nanobubble generator which is being placed in the water tank. Okay, thank you.